Hey everybody, let's get right back to where we left off last episode. Talking about audio. And I believe last time we talked about wavelength and basic acoustics. Yep, we were discussing a character of waves. So actually, for the beginning of today's video, before we start, how's everyone doing today? Please leave me a comment, let me know how you're doing, anything you would like to see in the future. And I have a new question for you guys today. What color highlighter should I start using? For these videos I have blue. I have this yellow, kind of lime greenish color. I have more of a teal turquoise color. A peach. And I have a pink. Let me get a sip of my water real fast. You'll have to excuse me. Whenever I record these videos, I'm getting right back from class, so it's jumping right back into things. I don't know about you guys, but I'm thinking I want to go with this peach color. It's a light peach. And then perhaps anything smaller will use a different color. So before we get too far into it, let's actually highlight these terms that we learned last time. Starting with compressed and its counterpart rarefied. Transverse waves, longitudinal waves, potential energy, and kinetic energy. And you know what? Let's do the characteristics of waves in a different color. Let's do blue before we get started. So we have 6 characteristics. That would be wavelength, period, frequency, amplitude, wave shape, and polarity. Ooh, polarity. Okay. Which leaves us today. We just finished wavelength. Now we're talking about diffraction, reflection, and diffusion. So let's go ahead and jump right into this. So all of these terms are pretty similar, again, to terms used in science. Talking about audio, it is a science. It is a physical wavelength that we have to study and understand to know how to make music, to know how to make sound. So let's start with, where should we put this? You think I should put it back on this first page on the back? Yeah, why not? Let's save some room. Save some room for the next. So we have diffraction. And diffraction is used in the sense of when a wave is bending. Bending is diffraction. So let's say the wave bends around an object to propagate. So what this means is, if the height and width of a surface are a lot smaller than the wavelength is, the wave will bend around the object and continue to move forward. Well, let's write that down. So, if an object's height and smaller than let's go ahead and use the term for the wavelength, which, if you remember from last episode, the wavelength is the Greek letter lambda. That's what we use to determine wavelength. The wave will diffract. Okay. On to our next term, reflection. And this is when a wavelength is reflected away. That's when we use reflection. Just like a mirror would have a reflection, it hits the mirror and bounces off. It's the same idea, but for sound waves. So let's say so it reflects away. I think reflect is a pretty self-explanatory one. We'll say if height and weight are, we'll say greater, we'll say larger than wavelength, it will reflect. Alright, and last but not least, we have diffusion. Diffusion is a little different. Let's see. I don't have an outright definition for diffusion. Okay. So basically, diffusion happens when there's a rough surface, something that's not entirely flat, or maybe like rocky terrain. Diffusion will bounce in several different ways. It's less predictable. Reflection, we know it will hit and come off at an angle. Diffraction, we know it will hit and go around. Diffusion, we don't have an exact definition of where it's going to go. So diffusion occurs when the wave encounters a rough surface. Okay, so let's say wave encounters a rough surface and the energy is scattered. We'll say scattered in many different directions. That's what we'll say. Let's say that. Okay. I think that's good for diffraction, reflection, and diffusion. Okay. Let's see. Here. Okay, this is a little bit more. This one's a little bit more interesting, a little bit more intuitive. You guys might not be lured to sleep by this one. So this one, I actually will be able to draw an image for you guys. So here we have the difference between fixed end and free end waveforms. So fixed end is when a wave is reflected at opposite polarity. So, just talking about reflection, we know that it will hit and reflect back. So, for example, a guitar string is an example of a fixed end. So, you pluck the string. Let's say you send a vibration at the top of the string, the very top. It will send a bump, and that bump will then travel at a peak down to the end of the string, and when it hits it, it'll send another vibration at the bottom of the string. So let me draw a little image of this real quick. Let's put this little arrow. And then when it hits back, it will send that this way. And then, hypothetically, this will continue as much as it needs. Oh, I messed that up. Okay. Okay. So let's say, let me draw a free end, and then I'll show you guys. Just one second. Free end is when a wave is reflected at the same polarity. So this one is more, honestly, I don't know if I know of an instrument off the top of my head that is free end. Certainly not an instrument that I play is free-ended. You'll have to excuse the noise. The city is quite active today. And then this will go all the way down. Okay. So let's say, let me show you the difference. So, if you can see this here, we have two fixed ends right here. A fixed end, you pluck the string here, it creates this attack, and it will travel down to the end of the string over here. And then, when it gets to the end, it will reverse and send it back to this end of the string. Versus a free end does not have an end on this side. You strike it, creates an attack, it will move down to the end of the string, and when it gets down here, it will just return the same attack to this end of the string. And that is a fixed end and free end polarity. And then these are words like pulse and that kind of thing are thrown around. If you remember from the last video, we talked about that. There is actually a third continuation called a no end, which is hypothetically, if your string was to not have an end, it would never return. The attack would just go on forever. So there's also this idea as closed end, open end, instead of fixed end, free end, and we can talk about this really So in a closed-end situation, a wave is reflected at the same polarity. And in an open end, a wave is reflected at the opposite. So kind of the same as fixed end, free end. Is reflected at the opposite polarity. And all this means is that, let's say you have a tube, for example, a chime. This is your chime. If you strike the chime here, a wave will travel through the chime to this end, hit the closed end, and travel back up to the top of the chime, out either through an open valve or whatever might be a release. If there is no release, it will just continue to bounce. But an open end, let's say a flute or a clarinet is a good example. Clarinet has an open mouth at the end, and the mouthpiece on this end. You blow air through this one, it sends a wave, and then it leaves. It's gone forever. However, a reverse wave is sent back up through the tube after the release. So the sound wave leaves, and let's say, you can visualize it as air. A little tiny wave of air comes in and pushes the molecules back, filling the instrument, creating a little bit of resonance. So if you play a note is played, resonance back through the tube. So, in review today, we went over diffraction, reflection, and diffusion, which are, again, more properties of these waves that we've been talking about. This section is a lot about understanding waves and the principles of waves. So we talked about diffraction, reflection, diffusion, and then we also talked about fixed end, free end, talking about strings and vibrations and pulses sent through strings, and then closed end, open end, vibrations sent through air, through tubes. And that is all I have for you guys today. Thank you very much for tuning in and giving me a little bit of your day. Please give me a like and a comment. It helps out more than you know. And if you're coming back again, go ahead and subscribe. We're going to keep learning and talking about this stuff together. So until next time, I'll see you then.